is quiz 3, question 3, bonds. So we work for a bond fund. We're trying to price a bond that has 15 days till its next coupon payment. You want to know the fair price. We have some information about the bond right here. What's the price of the bond? Okay, let's start a new page and zoom in a little bit. I did this in class, but there's a bunch of different ways to do this. I'm going to explain one of them here, and I think this is the one that, in my opinion, you should use. So, I know. All right, so you can draw a timeline, and if you do it in semi-annual periods, because this bond is semi-annual, and if you put payments on the timeline, so the first bond payment occurs, it doesn't matter how you look at it, but in this case, if you look at it as occurring at time 0, and then the next one's occurring until you reach the end of the life of the bond, if you can get the price here, you can discount it 15 days using the effective daily rate. And that's the best way to do this problem, in my opinion. There's another way that you can do it where you start at, it's essentially like 182 days minus 15 days. You can look at the solutions that I uploaded. In my opinion, that's way harder. Okay, so step 1 is to calculate the coupon payment and figure that out. So the face value of the bond is $10,000. Let's look at the interest rates. The coupon rate is 7.5%, and it's compounded semi-annually. So the coupon rate, 0.075, which means that the coupon itself is going to be $375. The bond, there are 13 payments remaining. I'm going to go ahead and I'll just chart this out so you can see. When you're right here, you're going to get $10,375 because you get the payment for the bond back. You can do this any number of ways. I'll do it the long way first, and then we'll go from there. Okay, so we have a yield to maturity of 9.5%. So, 0.095. So that means the effective semi-annual is going to be that divided by 2. All right, so let's do it the long way first. All right, so here's the long way, and the answer is that the price of the bond at time 0, standing at the first coupon pay or the next coupon payment that's going to happen, is $9,400. And I did that by charting out the number of coupon payments that are left and the repayment of the principal at the end, and then just discounting at the effective semi-annual rate. You can totally do this on an exam. There is no problem with doing it. In my opinion, it is the easiest way to do it. The short way, the present value, okay, so if we do a present value formula, the present value is going to assume that payments start on time 1. So what we have to do is add in the payment from time 0. And we also have to remember that it's going to spit out a negative number. So let's pretend that I'm just getting the value of the number of periods is 12. Notice it's 12 because we're not counting, oh, I did that wrong. There are 13 coupon payments left, so this should not exist. This is going to be 10,375. There we go. I'm sorry. So we had And let me just make sure I say this right. We have 13 coupon payments left. The first one occurs in 15 days. I'm going to call that time 0. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 payments. That's the correct price. Let's make sure it doesn't reference some ghost cell. There shouldn't be anything in there anyway. Okay, now the short way. The rate is this. The number of periods, again, 13 left, but we're not counting 0 because of the way the PV formula works. So 12. The payment is $375. I'll just click that one. And the future value is $10,000 because that's how much they're going to pay me at the end. Notice that we don't get the same answer. So first of all, put a negative in front of it so you get the right thing. And then add the payment that occurs at time 0. And we get the same answer. So that's cool. We're doing the right thing. The last thing that we need to do is discount it 15 days. So let's get the effective daily rate. And we are going to do this by doing 1 plus the effective semi-annual rate. And again, if you don't do it to the 1 plus, you'll get some weird teeny tiny answer. It won't be right. You have to do the 1 plus to move it from one rate to the other. And then if we square it, we get the annual rate. And then if we divide by 365, we get the daily rate. And you can subtract 1 if, well, let's do that anyway, just to make it the same. So this is a percent. These are all percents. And now let's discount it back. Let me add a line here. Let's discount the price back from here to here. So those values are the same. We can use whichever one. 1 plus the effective daily rate. So we're going to take the present value at time 0, discount it back 15 days using the effective daily rate. That's the effective daily rate to the power of 15 because there's 15 days. And lo and behold, the fair market price is going to be $9,439.97. I'm guessing that the 67 cents has to do with a rounding error. You would not have to get it that close on the exam. But that's the way that you do it, and that is the solution to this problem.